Welcome to this module on PC memory, a topic that turns out to be surprisingly complicated and that has big implications for the proper functioning of a computer. We'll start with an overview of the basics. This clip presents a definition of RAM, a brief chat about how much is enough, and an introduction to the different types of RAM and how they are used. RAM stands for Random Access Memory, and it refers most often to a computer's working memory, that is, the operating system, the program a user is working with at a given moment, and any data file that's being viewed or edited by that program and user. We say that RAM is volatile because when we shut down the computer, the contents of RAM disappear. But the saving grace of RAM is that it's a lot faster than the kinds of storage that are persistent, that is, non-volatile. The random access part of the term derives from the fact that the computer can quickly access any part of the RAM space whenever it needs to. This is not the case for sequential access storage, such as tape cartridges, for example, in which we have to move the tape forward or backward, often at considerable delay, in order to get to the part that we need. Sometimes it's sort of fun as a side note to put these technologies into a little historical context. This is a picture of so-called core memory some 60 years ago, amounting to 1 kilobyte. That's KB, not MB, not GB, in which tiny ferrite cores were wound by hand with connecting wires. And here's a printed circuit board with RAM chips amounting to 16 megabytes, about 16,000 times more than the core memory device I just showed you, but still about 1,000 times less than what we typically find in PCs today, and at least 100 times heavier. This photo is from a mini computer that I set up for a client in the late 1980s. Well, the big question about RAM is, how much do I need? It's tempting to fall back on a general number such as 16 gigabytes, but if we want to be precise, the right amount for a given device depends on the size of the operating system. For example, Linux needs a lot less RAM than, say, Windows does. The size of the apps we want to run. A word processing program needs a lot less RAM than a 3D animation program. The size of the related data files, because they need to live in RAM too. Whether the computer will be used for one thing at a time or be expected to do multiple jobs at once, such as hosting virtual machines. And finally, how fast we need the system to be, because up to a point at least, more RAM will increase the device's operating speed. Well, it's important to note that the motherboard, the computer's main circuit board where the RAM will be installed, is going to set an upper limit on how much RAM we can install. On modern systems, that limit is usually higher than we'll need, but on older systems, it might be a constraint. So what do we use RAM for in a computer? It turns out it's not just one thing. The main use, like we were talking about a moment ago, is main memory for the currently running operating system, programs, and data files. And that's our primary concern in this module. But RAM is also used to store images to be displayed on our monitor. And that RAM may live on the motherboard or onboard our graphics card. Video RAM can also be shared with the operating system or dedicated solely for video purposes. Today's high-end video cards need as much RAM as entire computers from just a few years ago. Another use of RAM, and the reason that I'm showing you a photo of a CPU at left, is to act as high-speed working memory, for example for the main processor, which actually has 3 kinds of cache RAM stored on the chip itself, but also for internal hard drives and even network cards. Finally, RAM is used to store settings that we might make for the computer's hardware configuration using something called the BIOS or UEFI setup program. So RAM has many uses and forms, but the main facts to remember are that A, it's fast, and B, it's volatile.